So this is a scenario we're going to use to do some probability problems. A very oversimplified scenario. And this is based on a study of post-treatment behavior of a large number of drug abusers, suggesting that the likelihood of conviction within a 2-year period after treatment may depend upon the offender's education. They should totally, first of all, make a little apostrophe there, right? There. The proportions of the total number of cases falling in 4 education/conviction categories are shown in the following table. So this is an example of a joint probability table, and that means that the two variables that are in play here, the education variable and the status within 2 years after treatment, are driving what each of the individual cells in the table are, and those cells in the leaving aside the totals, the sort of inner cells, are going to add up to 1.00. So this is, one of the confusing things about tables like this is sometimes they can be conditional tables, sometimes they could be joint probability tables. If they're conditional, then it means that either the columns add to 100% or 1, or the rows add to 1. In this particular case, each of the individual entries, like 0.10, is telling you what percentage of the observed cases fall into the category of being convicted within 2 years and 10 years or more of education, right? This is saying that of the drug abusers that were analyzed, 10% of them were individuals with 10 years or more of education and who happened to be convicted within 10 years of treatment. The underlying study that this is based on is considering whether the this is actually sort of the hidden variable here. These are all individuals who are going through a treatment regime. We're not comparing them to a control group without treatment, but it's looking for whether the education level might be interdependent with the probability of success. So they're interested in whether, essentially a question of whether the program might work differently for those with more versus those more education versus those with less, right? Okay, so what this is saying, if we take these sort of proportions as a type of probability, if we treat them as probabilities, which is an option available to us, or at least as approximate long-run probabilities, then each of these we could actually write we can write these as probabilities. Let's actually think of let's make convicted or not convicted. We'll call that C to make things easier, right? So the convicted is going to be C. Not convicted, I could write C complement, but the two C's might get confusing. So this is a good place maybe to use just the not C for not convicted, and then education 10 years or more, 9 years or less. Let's, for simplicity, and let's call this variable, let's refer to the event of having higher education, 10 years or more. Let's call that E, and we'll call E complement, or just to make it consistent, we'll call it not E, right? So something like this, 0.30, the 30% or 0.3 probability. So you could think of this as if I randomly selected one of these individuals who's being studied, the probability that the person I choose has the higher level of education and is not convicted within 2 years of the treatment is 0.30. That's one way to write it. We could also write it, as we've seen before, probability of E comma not C, or probability of E and not C, right? Okay, so the the oh, actually, I chose E and C there, but then this was an example from a textbook. I forgot that they decided to give these events named A and B. A little bit annoying because we have to remember which one is A and B. It doesn't have a sort of natural connection to the letters E and and conviction. But let's stick with that. So we're talking about in that last case, we would be looking at and we can say the probability of having 10 years or more of education. So that's A intersect, and now I'll use the complement because the notation. So not convicted would be, so if B is the event of being convicted within 2 years, the amount under study, and not being convicted within that amount, which would be a success, one would think of the treatment program, would be that. So the probability of A intersect B complement is 0.30. Okay. So we're going to calculate a few probabilities using this table. The first one, simply probability of A, the probability that offender has 10 or more years of education, right? So some high school, and that works out to at least, right, sophomore year of high school and beyond. And how are we going to figure that out? Well, this is a marginal probability, right? We talked about this, which means we're interested in something that's going to be not in the inner cells of this table, but in the margins, right? Somewhere over here or over here in the totals, right? So which one is it? Well, all of those who have had 10 or more years of education, that's the top row, and the total are those with more education who then get convicted within 10 years, or not get convicted. It's that entire 40%. That's the margin we're interested in. So the probability of A is equal to 0.4 or 0.40. Probability of B, what's that? Probability of B is the probability offenders convicted within 10 years. Regardless, we're marginalizing over the other variable. That is to say, regardless of the level of education, just take someone randomly. What's the chance that if we randomly pick someone who went through the treatment program, a previous offender, that they are convicted of some crime within 2 years after completion of the treatment that everyone in this group is getting? Again, it's a marginal probability. We're looking for one of those numbers in the margins. And which margin do we want here? Well, what percentage of, what's the probability of being convicted within 2 years? It's all those that are in the convicted column, whether or not they had greater amount of education or less. It's the 0.10 plus 0.27, which is 0.37, right? And let's do one more, and then we'll break this up. So let's do the probability of A intersect B. So that's the probability of, if I pick someone at random from this group, right? If I take, someone who is going through the treatment program, the probability that the person I pick at random is someone with the higher level of education and who also has the unfortunate outcome of being convicted within 2 years of completion of the treatment. Both of those, that's a joint probability. That's combining. It's an and. It's looking at some outcome with respect to conviction or not conviction, and some event with respect to education. And specifically, it is this one here, right? Probability of A intersect B. That's the proportion for whom A is true and B is true. Oh, what the heck, let's do the union as well. And then we'll come back after to do these others with the strange notation, which is another type of notation for complements. So for D, the probability of the union is, right, at least one of those, right? It's A or B. And when we say A or B, in probability we mean A or B or both, right? So which are the outcomes that would count? Well, if there, we know that there are 40% that fall into the category of A having happened. That is, they're the higher educated, or 40% among them, the 10 years more of it or more of education. The B is referring to, again, convicted. So it's somewhat. So it's what's the probability that someone falls in the top row or the first column, right? So we can use our rule that you can probably just tell from. You can probably just look at this and get a sense from the just intuition, right? That what we're talking about is someone in one of these guys. We could actually say we could use the rule that it's the probability of A plus the probability of B. And what do we have to do? They're not mutually exclusive, so minus the probability of A intersect B. And those are actually the three problems we've done so far, right? We got that the probability of A was 0.40. We got the probability of B was 0.37. And we got the probability of the intersection as being 0.10. And so that's comes out to 0.77 minus 0.10 is 0.67, so 2/3 probability. Another way we could have also done that is to recognize that it is 1 minus the probability of the complement of the union A and B. That is to say, it's the probability of the complement of A union B, right, is 0.33. That's the chance that someone I picked at random from these observations over the long run happens to be in the more poorly educated group and the non-convicted group. And so if it's going to fall in one of the other categories, that's the probability of that is 1 minus the probability that it falls in this category that is neither, where A is true, A is not true, and C is not true. So another way of actually writing that is 1 minus the probability of A complement intersect B complement, right? Not A and not B. That's 1 minus 0.33 any way you write it, and 0.67, or about 2/3.